Hello and welcome to yet another video of Cornerstones of Math. If the point a, b is moving on a circle x squared plus y squared equals 1, what is the locus of the point a plus b, ab? You must also indicate the domain of the locus. So as this point a, b moves on a red circle, point a plus b, ab creates a different curve, which is called the locus. And we must find the equation of this locus as well as its domain. So the solution consists of two parts: finding the equation of the locus and finding its domain. And the cool thing about this problem is, not only there are different methods to find the equation of the locus, but there are also several different methods to find the domain as well. So let's jump right onto the problem to find out all those super cool methods. So in this first method, I will show you the most common method to find the locus. We start by letting a plus b, ab as x, y in capital letters, because this is our special point of interest rather than some random arbitrary points. Finding the equation of the locus means finding the relation between these new variables x and y. That is, finding this function f that correlates these two variables. In order to do that, we use the relation between a and b, which was already given in the problem. That is, point a, b is moving on a unit circle x squared plus y squared equals 1, so it must satisfy the equation of the circle. So we have a squared plus b squared equals 1. And by using the famous formula, we have a plus b squared minus 2ab equals 1. And this a plus b is capital X and this ab is capital Y. So we can change this equation into x squared minus 2y equals 1. And if we solve for y, we have y equals 1/2 times x squared minus 1, which is the relation between x and y. So this is the equation of the locus, which is a parabola. Now what would be the domain of the locus? Here I will show you not one, not two, but actually three methods to determine the domain. The first method is using the fact that x and y are respectively the sum and the product of two variables a and b. This means that a and b are actually roots of the quadratic equation t squared minus xt plus y equals 0. This is because the quadratic equation having a and b as roots can be expressed as t minus a times t minus b equals 0. So t squared minus a plus bt plus ab equals 0. Therefore t squared minus xt plus y equals 0. So this equation gives two roots a and b. But these a and b are not just two roots. They are two real roots. Here we are using the fact that this quadratic equation has real roots. This means that the discriminant of the quadratic equation must be non-negative, so we have x squared minus 4y is greater than or equal to 0. We have already obtained that y equals 1/2 x squared minus 1, so using this, x squared minus 2 x squared minus 1 is greater than or equal to 0, which gives x squared is less than or equal to 2, so we have x is greater than or equal to minus square root of 2 and less than or equal to square root of 2. And this is the domain of the locus. Therefore, the locus of the point a plus b, ab is y equals 1/2 x squared minus 1, where x is greater than or equal to minus square root of 2 and less than or equal to square root of 2, which is this blue curve in the figure. But this is not the only method to find the domain. Let us find the domain by different approach. Here we start from a squared plus b squared equals 1. Point a, b is on the unit circle. Then we use the famous inequality of arithmetic and geometric means, which gives a squared plus b squared is greater than or equal to 2 times square root of a squared b squared, and this a squared plus b squared equals 1, so we have 1 greater than or equal to 2 times, and we can write this as an absolute value of ab, and this ab is y, So we have 1 is greater than or equal to 2 absolute value of y, which gives absolute value of y is less than or equal to 1/2, which means y is greater than or equal to minus 1/2 and less than or equal to 1/2. Now let us convert this to the range of x using the previously obtained equation of the locus. Here we have 1/2 x squared minus 1 is greater than minus 1/2 and less than 1/2. So x squared minus 1 is greater than or equal to minus 1 and less than or equal to 1. So x squared is greater than or equal to 0 and less than or equal to 2. And this greater than or equal to 0 part is obvious. And from this less than or equal to 2 part, we obtain x is greater than or equal to minus square root of 2 and less than or equal to square root of 2. So we have arrived at the same domain. Still, we have another method of finding the domain. Finding the domain, third method. Here, we will use the Cauchy-Schwarz inequality. It's actually more general than what is shown here, but for our specific problem, we only require some of the simplest forms of the Cauchy-Schwarz inequality, which is, for real numbers u1, u2, v1, and v2, u1 squared plus u2 squared times v1 squared plus v2 squared is greater than or equal to u1 v1 plus u2 v2 squared. In our problem, x equals a plus b, hence we want to determine the range of a plus b. Therefore, in the Cauchy-Schwarz inequality, we let u1 as a and u2 as b, and v1 and v2 as simply 1. Then we have a squared plus b squared times 1 squared plus 1 squared greater than or equal to a plus b squared. Using that a squared plus b squared equals 1, we simply have 1 times 2 is greater than or equal to a plus b squared. So a plus b is greater than or equal to minus square root of 2 and less than or equal to square root of 2, which gives x is greater than or equal to minus square root of 2 and less than or equal to square root of 2, which is exactly the same result as previous ones. Okay, we have obtained everything asked in the problem, but do you remember that there exists more than one method to find the equation of the locus? Well, here I will show you another method to find the equation of the locus, this time using trigonometric functions. Since a, b is a point on a circle x squared plus y squared equals 1, we can express a, b as cosine theta, sine theta, because cosine squared theta plus sine squared theta equals 1. In this way, point a, b is now expressed in terms of single variable theta, which can be called the parameter. Then point x, y, which is a point a plus b, ab, is now given as cosine theta plus sine theta, cosine theta, sine theta. So we have x equals cosine theta plus sine theta and y equals cosine theta times sine theta. This is some sort of a parametric equation where x and y are related by this parameter theta. In order to obtain the relation between x and y as an explicit y equals fx form, we have to eliminate the parameter theta. And we can do that by squaring the first equation, which gives x squared equals cosine squared theta plus 2 cosine theta sine theta plus sine squared theta. And using that cosine squared theta plus sine squared theta equals 1, we have x squared equals 1 plus 2 cosine theta sine theta. And since cosine theta sine theta equals y, we have x squared equals 1 plus 2y. Therefore, we have y equals 1/2 x squared minus 1. Here, the parameter theta is eliminated, and we obtain the relation between x and y. Now, can we find the domain from this trigonometric method? Well, of course we can, and that leads to another method for the domain. Here, x is given as cosine theta plus sine theta, so we have to find the range of cosine theta plus sine theta. This can be done by so-called harmonic addition of the trigonometric functions. That is, if you have an expression in the form of a cosine theta plus b sine theta, we can convert this into a single trigonometric function, for example, like this c times cosine theta plus alpha. And this is quite simple actually. It is just a reverse process of the angle addition formula of trigonometric functions. For our case, cosine theta plus sine theta can be written as square root of 2 times cosine theta minus pi over 4. Again, this is a very simple process if you have already learned the angle addition formula in trigonometry. And this simply gives the range of x as greater than or equal to minus square root of 2 and less than or equal to square root of 2. And this is our domain. Or, in our case where the coefficients of cosine theta and sine theta are equal, we can just square the expression for x to obtain 1 plus 2 cosine theta sine theta, by using cosine squared theta plus sine squared theta equals 1, and by applying the previously used arithmetic mean geometric mean inequality, this expression is less than or equal to 1 plus cosine squared theta plus sine squared theta, and again this is 1, so we have 2. So we have x squared is less than or equal to 2, which also gives x is greater than or equal to minus square root of 2 and less than or equal to square root of 2. See, there are just so many methods we can use to determine the domain. In conclusion, we have the locus y equals 1/2 x squared minus 1, where x is in between minus square root of 2 and square root of 2, which is a part of the parabola. Lastly, let us visualize how the point a plus b, ab moves along the locus as a and b changes using the Desmos graphing calculator. Here, the red circle is our unit circle, and the green dot is point a, b. As you can see, it moves along the circle. Then we have blue dot, which is point a plus b, ab. And as you can see, the blue dot moves along the black curve called the locus, which is the parabola that we just obtained. And that was all for today's video. Thank you all for watching, and I will see you in another video.